All right, we're in the Helicopters Flying Handbook, Chapter 11, page 7 to 24, Power Failure in a Hover. Power failure in a hover, also called hovering auto-rotation, is practiced so that a pilot can automatically make the correct response when confronted with engine stoppage or certain other emergencies while hovering. The techniques discussed in this section are for helicopters with a counterclockwise rotor system and an anti-torque rotor. Technique. To practice hovering auto-rotations, establish a normal hovering altitude, approximately 2 to 3 feet for the particular helicopter being used, considering load and atmospheric conditions. Keep the helicopter headed into the wind and hold maximum allowable RPM. To simulate a power failure, firmly roll the throttle to the engine idle position. This disengages the driving force of the engine from the rotor, thus eliminating torque effect. As throttle is closed, apply proper anti-torque pedal to maintain heading. Usually a slight amount of right cyclic control is necessary to keep the helicopter from drifting to the left to compensate for the loss of tail rotor thrust. However, use cyclic control as required to ensure a vertical descent and level attitude. Do not adjust the collective pitch on entry. Helicopters with a low inertia rotor system settle immediately. Keep a level attitude and ensure a vertical descent with the cyclic control while maintaining heading with the pedals. Any lateral movement must be avoided to prevent dynamic rollover. As rotor RPM decays, cyclic response decreases, so compensation for winds will change, requiring more cyclic input. At approximately 1 foot AGL, apply upward collective pitch control as necessary to slow the descent and cushion the landing without arresting the rate of descent above the surface. Usually, the full amount of collective pitch is required just as the landing gear touches the surface. As upward collective pitch control is applied, the throttle must be held in the idle detent position to prevent the engine from re-engaging. Helicopters with high inertia rotor systems settle more slowly after the throttle is closed. When the helicopter has settled to approximately 1 foot AGL, apply upward collective pitch control while holding the throttle in the idle detent position to slow the descent and cushion the landing. The timing of the collective pitch control application and the rate at which it is applied depend upon the particular helicopter being used, its gross weight, and the existing atmospheric conditions. Cyclic control is used to maintain a level attitude and to ensure a vertical descent. Maintain heading with anti-torque pedals. When the weight of the helicopter is entirely resting on the landing gear, cease application of upward collective. When the helicopter has come to a complete stop, lowering the collective pitch to the full down position. The timing of the collective pitch is a most important consideration. If it is applied too soon, the remaining RPM may not be sufficient to make a soft landing. On the other hand, if collective pitch control is applied too late, surface contact may be made before sufficient blade pitch is available to cushion the landing. The collective must not be used to hold the helicopter off the surface, causing a blade stall. Low rotor RPM and ensuring blade stall can result in total loss of rotor lift, allowing the helicopter to fall to the surface and possibly resulting in blade strikes to the tail boom and other airframe damage such as landing gear damage, transmission mount deformation, and fuselage cracking. Common errors of power failure in a hover. Failure to use sufficient power anti-torque pedal when power is reduced. Failure to stop all sideward and backward movement prior to touchdown. Failure to apply up collective pitch properly, resulting in a hard touchdown. Failure to touch down in a level attitude. Failure to roll the throttle completely to idle. Failure to hover at a safe altitude for the helicopter type, atmospheric conditions, and the level of training proficiency of the pilot. Failure to go around if not within limits and specified criteria for safe auto rotation. All right, that was page 7 and 8 of chapter 11. That is power failure in a hover. See ya.